Hello guys, welcome back to my YouTube channel. Today we are diving into the phenomenal world of Arduino. If you have ever looked at the complex machines or cool gadget, wonder how that actually works. Arduino is the single most important tool in the modern maker revolution. My goal today is to give the foundation you need to live here and start the building your first project tonight. Let us discuss what actually the Arduino is. Arduino is nothing. Its core Arduino is an open source electronics platform. It is the perfect combination of two things. One is hardware, another one is a software. Okay, hardware is nothing, the physical circuit board that I will show you later, and software is a development environment where we will write the code. And microcontroller is the main thing in the Arduino which will work as an a brain. Okay, next we will come for why Arduino is needed, why it is making that much revolution. Okay, first thing is that it is easy to use. We can use it very easily because it is written, we can write the code with simple programming language C and C++. And also we can get it at very low cost, and it can be accessible to all the students. They can buy and they can make a creative project. And to understand it, there are many tutorials, many guides, many open source projects are available online. Now we will see the different families which are present in the Arduino. The most famous board that what we use is an Arduino Nano, which is what we focus on it, and it is the standard board. But you should know its relatives also, right? Its relatives are nano, mega, based upon our project. Suppose if our project needs very small space, we have only small space where we need to fix the Arduino, then we can use Arduino Nano for a compact size. If there is any complex automations, robotic thing is there, then we need to use Arduino Mega as it contains the huge number of pins, high pin out projects like 3D printers or advanced robots. We will use the Mega. Based upon our project requirement, we will use this Arduino, Arduino Uno, Nano, Mega. Okay. Now we will see the anatomy of an Arduino Uno. How actually it is. It is very simple. See, here let me use the laser pointer. See here, these all things are digital input pins. These will work based upon our code, what we will give, like input, output. So whatever the digital things, we will give here, input and output. And suppose there are some inputs, we will give it as an analog input. So these things are called as an analog inputs. For example, there is a sensor called as MQ3 sensor, which will work based upon analog because it will sense the value. We will give some value based upon it, that it will work. So whatever the analog things we will get, we need to connect for these pins. Whether this is digital input and output, this will just do low and high, on or off, on or off. These things we will give here based upon some value where that sensor need to work. For that we will use the analog input. For whatever the operation here is happening, the main responsible is this microcontroller chip at Mega 328P. This is the brain of this Arduino which will work. And there is a reset button here. When we will press this one, whatever the code is written, it will start from the beginning. And here we have 5 volt and 3 volt output what we can give, and ground. This is the standard Arduino. In this also we will get a clone Arduino also. That will be a cheaper for your project. Working on that, we can bring those all things. And there will be built in an LED, which will blink continuously. Suppose think that the Arduino is not blinking when the program is uploaded, then we should think it is a dead, or we need to do it. We need to burn that chip. We using the burn bootloader. Okay. Uh, Next we will go for input and output conversion. How actually it happens. Okay. How the input is taken, how the loop will work, everything we will see. This is the core concept of an embedded system. And Arduino is an intelligent translator, right? Input is the how world take to it, right? How the world talks to the Arduino. Example, the button is pressed, or a temperature, there is a change in temperature. So like what we will give here, it will take button is pressed. So this the input will become high, low, based upon what we given in the code. So this loop is working continuously, repeatedly until our logic ends. Like this conversion will happen. Suppose if you have given when the button is pressed, bulb should be on. So the loop is continuous, right? Button is pressed, LED on. Like this, how the conversion will happen. Now, whatever the thing will happen based upon what we will give, that magic will happen inside the Arduino IDE. That is the software what we are using to write the code. Here there is an editor where we will write the code using C++, and after clicking that we will click on verifier. So it will compile, it will check whether is there any errors in that. Later we need to upload it. We will send that code via USB cable. What the code is written, we will send it. Okay. Whatever this all logic is there, we will write, we will give in our code. And we will see the anatomy of a sketch. Every Arduino program called sketch, it has mainly two functions. One is void setup, and other one is void loop. Void setup is nothing but it runs only once when the board power up or a resets. This is where you initialize the components. Okay. While loop runs continuously after setup finishes. This is the main engine of your program, constantly checking the sensor and updating the outputs. These are the two main things as a basic you need to understand here. Next, we will understand some data and comments. Okay, there will be variables like all programming language. We have variables and data types, and also we will give some comments for the human understanding, right? Suppose here we will have variable that will store the data like numbers or its states, and data types int, float, boolean, whatever we might give based upon our need. Okay, next we will see one project, hello world. Okay, I will explain here how it should work. Based upon that you can do it. Okay, here this is a simple hello world project. Okay, the goal is to simple turn on the LED for 1 second, then off for 1 second. Okay, for this we need one LED and 220 ohm resistor and one Arduino Uno. Let us see how we will make this. This is very simple, as I said. Okay, first we will give the in setup, as I said, two things to you, one setup and one loop. In the setup we will use digital pin mode 13 output, okay, to tell the Arduino that pin 13 will be sending the signals. And in the loop what we will write, digital write 13 high, it will send the 5 volts, turning the LED on. So digital write 13 low, what it will make, it will send the 0 volts, turning it off. And we will add a delay of 1000 milliseconds, means 1 seconds. It will pause the entire program for 1 second. This is the simple combination of timing control. Like this, we can achieve that LED turning on and off. Okay. Next, we will see working with an digital input, how it will work based upon that. Now for input, we will use a simple push button. When the button is pressed, the Arduino reads high, that is 5 volt. When the button is released, it reads low, that is 0 volts. We often use a pull down resistor to make sure signal is clean and doesn't float when the button isn't pressed. Okay, let us now we will go for deep dive into the code. We have used the function digital read input, that is to check the state. The power of Arduino comes from using that input to make the decision using the conditional logic if or else. If the button reads high, we run one block of code, like turning on the LED as I said. If it is else, it reads low. We can another like do the another function like turning off the LED. Now this is how it will work. Let us understand this breadboard. To wire these all components without the soldering, we will use the breadboard. Okay. This is simple as you all know. Here we have same current. Here we have same current, and here in this section we have all same current. This is become easy while giving connection for VCC and ground. If we give VCC here, all 5 volt is here. From this we can take and we can maintain the same volt for the other sensors. Okay, this is just like without soldering we are using the breadboard. It will help for the students to easily embed it and remove it. Okay, next project 2, that is traffic light control. The real world is just not only on and off. It is continuous, right? Analog input. How is Arduino reads this continuity? That is nothing a voltage range from 0 to 1. Here we will make a simple traffic light control using three LEDs, red, yellow, green. Just this is the project of combining multiple LEDs and a time logic just to understanding and mastering of a time sequences. We will use the digital write and delay in the specific order. I just now I said the real world is not only just on and off, it is continuous. Some based upon some analog input values, the Arduino need to work here. Okay, ADC is nothing but it is analog to digital converter. That a voltage is an whole number, right? It will convert to some values. I said the analog value will be from 0 to 123. Digital pin is nothing 0 or 1, either high or either low. Analog pins are from A0 to A5. They are non Arduino, so they will read the data from the sensor and that will transfer to the Arduino as a either 0 volt or a 5 volt. This range is the raw data you work with whenever reading the sensor. I said like MQ3 sensor. It will read the data. Based upon that will work. Now let us come into the code. We will use analog read A0 to read that value from where to where? From 0 to 1023. That will read the value from analog pin A0 pin only. Okay. But if you want to use that raw value to control something, it has a different range. Like in our project, we want to make that LED dim, right? Like an LED dimmer that runs from 0 to 255. In that case, what we need to do that LED dimmer should it will work in the range of 0 to 255. So we will use a map function. Okay, this one we will use. This will take the sensor value and mathematically scales it from input range to output range. This function is incredibly useful. Now, Arduino, this is how an example how the analog will be written. Now, the dash thing is analog output, that is PWM. That is nothing but pulse width modulation. Arduino cannot output two analog voltages, so it will make a cheat. So it switches a digital pin on and off thousands of times per second. If it is on for 50% of time, average voltage is 2.5 and the LED appears half bright. We call this as a duty cycle. Okay. Only pins with only pins with this symbol supports the PWM function. Okay. Now we will see the code. The function analog write pin value. The value range for PWM is 0 is off, 255 is on. Okay. Range is 0, that is always off, 255 is always on. This is why we often map from 0 to 1023 sensor input to 0 to 255 PWM output. For example, Analog write is 11, 127. Sets the LED to roughly half brightness. So it will not take full brightness, half brightness, that is 50%, approximately 2.5 average old. Now we will see how we will gather the data using the different sensors. Okay, we for environmental we have temperature data. To collect about temperature we have that sensors. To collect the humidity we have that sensors. To check the air quality we have sensors. For all these things we have sensor. If you want to check the motion we have PIR sensor or accelerometers or gyroscopes. These all things works based upon the motions. Whenever there is change in motion, whenever a person is moving or something is shake, based upon that the sensors will work. And to check the distance also we have some sensors like ultrasonics or infrared proximity. Like this we have sensors to check on distances. Now let us come how to measuring distance. To measure sense to measure the distance we have ultrasonic sensor as I said. Okay, just this sensor is used. Whenever the object comes near it will tell the distance. Whatever we will fix in the code based upon that it will work. And if in order to move the things to work that thing we have some DC motors and servo motors. DC motor is nothing but it will spin continuously. Okay, based upon the motor driver this will work. So Arduino pins cannot supply enough power to them. We need to use separate power, otherwise there will be a fluctuation in current. Other servers, other motors will not work properly. And servo motor, it can rotate the specific angle from 0 to 180 degree. So this will work great for robotic arms or other things, or opening or closing something. There also we can use this servo motors. For controlling servos, that is servo motors, we have servo libraries. Okay, these will make how that servo motor should work. If we wrote my servo dot write 90, that will make you move that servo motor 90 degree. If we write 180, and that will make move to 180 degree. So other sensors, if want to give the feedback, so we can say it by using the displays. That is LCD 16 into 2. It is a standard text display. Here we can write one sentence, and below one sentence we can write two. Instead of connecting these wires, we can use I2C, which will mainly take only 4 pins if we use I2C. Okay. Next, we will go for libraries. We can say libraries are the superpowers. What actually the libraries are? They are the pre-written code packages that will handle the complex hardware communication for us. Yeah, it will reduces the number of lines of code as the code is already written. Just we are using. We will install them using the library manager in the IDE. It is the software. In software, just we can go inside the library manager. There we will select these libraries. Okay, for servo motor this library used for LED, for what at the display we will use this uh, library. And serial communications in our software we can see the above part what it is written, that is the editor part. After clicking this one we will see the serial monitor. Here what the data is happening, what we write the code we can check here whether it is working correctly or not with audio, what signal is going, what is coming, what is wrong. We can understand through here. From here we can set the bond rate. Another thing, the bond rate should be same here and in the code, then only it will work properly. Usually we will set the serial dot begin 9600. Okay. If we write serial dot println server value, that server value will come here. This will easy to check. This is called as a serial communication. Next, how to power this Arduino. While giving the code, we will upload it using the USB. From there only the code will go to the Arduino. Once programmed, Arduino doesn't need the USB again. Okay. Once the program is dumped, it will go inside the microcontroller chip. It will store there. Afterwards, we can remove that USB. You can give power here using 9-volt battery. We can give to this barrel jack, or also you can give here in this. We have V in here. We have V in this pin. We can give their power. Here the power it will come to all. And another thing, if you give power here and if you taken V in here and given to somewhere, it will take the direct power how much it is coming. Suppose it is coming 12 volt here. You have connected the sensor in V in, then that sensor will burn because how much volt is coming here, that much only comes in that V in. So don't connect anything there. We should use this 5 volt and 3 volt only.
Shields and modules. To take our project to the next level, we keep some shields. They are pre-assembled nodes that stack directly on the Arduino, like Ethernet or a Wi-Fi shield for instant connectivity. And the modules are they are smaller, self-contained units like GPS or Bluetooth that connect to our wires. And next, what I can say is the future is yours. Like Arduino is the foundation for automation. That is smart lighting, automated watering, and robotics, that is line following robots, custom drones, and scientific data logging, that is recording the weather data. Your imagination is the only limit. You have the foundation now to solve the real world problems